Hello, everyone, and welcome to our 2018 Hurricane Season Forecast webinar. This is Sophie Guilbeault from the Institute for Catastrophic Loss Reduction, and I have the pleasure of welcoming Bob Robichaud from the Canadian Hurricane Center today to give us an overview of what the 2018 hurricane season will be like. Bob Robichaud received his Bachelor of Science in Meteorology from Lyndon State College in Vermont. After a few years as a weather forecaster in the private sector, he joined Environment Canada in '98 as an aviation forecaster in Gander, where he eventually became Aviation Weather Program Manager for Atlantic Canada. He then moved to Halifax in 2004 to fill the new Warning Preparedness Meteorologist role in Atlantic Canada, where his primary focus is working closely with emergency management officials on a variety of different weather-related issues, including training, exercising, and support during actual weather events. Before I pass it to Bob, I would just like to remind you that if you have questions during the webinar, please write them down in the question box, and I will make sure to ask them to Bob at the end of the webinar. So thank you, and with that, I'll pass it to Bob.
Okay, thank you, Sophie. Welcome to this year's briefing. After what was really a historic hurricane season last year. So what I'm going to talk about today is essentially, we'll just give you a brief overview on what these storms are. Since we only deal with them during a certain time of the year, it's good to review what these things are. So once we do that, I'll take a look back at 2017 and just look at some of the storms that we got last year, and then we'll look at what we might expect for this hurricane season, and then I'll finish up by going just showing you a couple of techniques, if you will, or priorities as to what kind of information to look for and where to find that information when we have a storm approaching. So first of all, tropical cyclones. When I say the word tropical cyclone, that's really just a generic term for all these types of storms, which include hurricanes, tropical storms, tropical depressions, typhoons. They form over the warm tropical waters around the world, and as I say, sometimes they have different names in different ocean basins, but essentially they're all the same type of storm, and they actually serve a purpose. They are there to redistribute energy that's stored in the ocean in the form of heat. So as the sun heats up the oceans, that creates an imbalance, and nature tries to counteract that imbalance by taking some of that energy and pumping it into the atmosphere. And the most efficient way to do that is through the formation of hurricanes. And you can see the map here at the bottom. We don't tend to get hurricanes forming near the equator. That's because there's not enough spin there to actually get a hurricane going. So they occur just off of the equator, both north and south. And so in the western Pacific, they're called hurricanes. In Eastern Pacific and the Atlantic, they're called typhoons in the Western Pacific, and hurricanes in the Eastern Pacific and in the Atlantic Ocean. In the Indian Ocean, for example, they're called just purely cyclones. So the different names, but essentially the same storm. Now, in the Atlantic is what we're mostly concerned about, and at least for North America. And we tend to see these storms form at different locations in the Atlantic, given the time within the hurricane season, which starts on June 1st, basically tomorrow, and then runs until the end of November. So early in the hurricane season, they tend to form where the water is warmest at that time, and that's usually the Gulf of Mexico or somewhere around the Caribbean. That's where we typically see our first storm, which is the case this year with Alberto. Once we get into July, same kind of thing, but then once we hit August, that area where we tend to see most of the storms develop is over the eastern Caribbean and then more towards the middle of the Atlantic, and that brings us to September, which is the peak of hurricane season, and then things start to wind down again in October, and then we just get a few storms during the month of November on the average. Now, there's certain things that we look at for the development of tropical cyclones. Again, since these things are there to redistribute heat that's stored in the ocean, the warmer the water, the more likely you are to have a hurricane developing. So we have to have ocean temperature that is quite warm, usually above 26 degrees Celsius, and that layer of warm water has to be sufficiently deep. We typically look at a couple of hundred feet of warm water to get a hurricane going. We also need an unstable atmosphere, meaning that the lower levels of the atmosphere are warm and humid, and the upper levels of the atmosphere are a bit colder, and that creates an unstable atmosphere, which is another thing that we look at for the formation of these storms. And I mentioned earlier that they don't form near the equator. You have to be at least about 500 kilometers on either side of the equator for these things to develop. Otherwise, there's just not enough spin to get the thing going. Usually what we look at is a pre-existing disturbance near the surface, which starts to develop a more organized area of thunderstorms, and that's usually another thing that we look at for the possible development of tropical storms and hurricanes. The other last thing is an environment that has low wind shear, so very little change in the wind speed and or direction as you go up in the atmosphere. So those are all the things that we look at for the formation of tropical cyclones. Now, once they do form, the air rotates in the Atlantic and in the Pacific, the northern Pacific Ocean, and the North Atlantic. The winds rotate counterclockwise around the center, and as you go towards the center of the storm, the conditions get progressively worse and worse and worse till you get right in the center of the storm, and things are actually relatively calm in the center. And if the storm is strong enough, you tend to get clear skies right down the middle of the storm, and that's what we call the eye of the hurricane. And we had a number of examples of those last year where it was clear right down to the ocean surface. So as you go towards the center of the storm, the pressure gradually decreases and starts to decrease a little bit faster as you get towards the center. The wind speed is the opposite. It gradually increases, reaching a peak intensity right at the what we call the eye wall, or the last layer of clouds before you reach the center of the storm. Then the winds drop off dramatically. However, if the storm is going right over you, the other side of the storm is going to eventually go past you, and the winds will increase extremely rapidly. So we always, tend to warn people of that, and to try and get them not to go out if they're in the eye of the storm. And we got a good example of that last year, which I'll show in a couple of minutes. So we classify these things solely by their sustained wind speed. So assuming we have a storm that's developed and the winds are at least 63 kilometers per hour, that's when we give it a name, and it is classified as a tropical storm. If the winds reach 119 kilometers an hour, that's when it gets classified as a hurricane. And of course, there are 5 categories of hurricanes with 3, 4, and 5, basically with winds of over 178 kilometers per hour being classified as a major hurricane. So these types of storms occur, again, during most of them are within hurricane season, although there have been a few that have developed outside hurricane season. But most of the ones that we have to deal with in Canada do occur within hurricane season, but they are quite different than what we typically deal with as far as storms go. In the case of the tropical cyclone, its whole existence is because of warm water, and it's fueled off of that warm water. Whereas the non-tropical cyclone is fueled by the difference in temperature between northern latitudes and southern latitudes. In the case of a tropical cyclone, it's slow moving, whereas a winter type storm moves quite a bit faster. And in the case of a tropical cyclone, it's quite symmetric around the center of the storm, whereas a non-tropical cyclone is certainly asymmetric. And you see the satellite images at the bottom here. This, the one on the left is Major Hurricane Irma from last year, and you can see how symmetric it is around the eye of the storm, whereas the major winter storm that we had here in eastern Canada this past January, you can see how the cloud pattern is not symmetric compared to the case of a hurricane. Now, what we have to deal with most often here in Canada is a storm that goes from tropical to what we call post-tropical, or something that looks more like a winter storm. So a typical scenario would be a storm forming off the coast of Africa. In that case, the wind and the rain around the storm is quite symmetric, and the storm is moving slowly, and then it intensifies. Again, both the wind and rain are symmetric around the low. As the storm starts to move northward, it starts to pick up speed. And not only does it pick up speed, but it starts to dry out on the right-hand side of the storm, and the storm actually gets bigger. The maximum wind speed may not be quite as strong, but the storm covers a larger area. And as the storm dries out on the right side of the storm, that pushes all the rain to the left-hand side of the storm. So very often when the storms reach Canada, we have a very distinct pattern with the heaviest rain on the left-hand side of the storm, or the left-hand side of the storm track, while the strongest winds are on the right-hand side of the track. And that's something that occurs quite often when the storm moves into northern latitudes. So because of that, typically your areas of heaviest rainfall, so your hazard areas for rainfall, would be the left of the track, and your strongest winds to the right. Because the strongest winds are on the right, that's where you're going to find your worst storm surge and your highest waves. So the combination of storm surge and pounding surf and wave damage is usually going to be on the right-hand side of that track, wherever the track goes. So those are things to keep in mind as we get into hurricane season here. So with that, I'll go back and look at what we were dealing with here in 2017, which again was a very active hurricane season, more active than we'd seen in quite some time. Last year at this same briefing, the forecasts that we were talking about, which were issued by NOAA, called for 11 to 17 named storms, 5 to 9 hurricanes, and 2 to 4 major hurricanes. And you can see what actually happened. We got 17 named storms, 10 hurricanes, all in a row, by the way, and 6 major hurricanes. And so we got all the way up to Rena in November, and we had 4 names that were retired from the list of names that we rotate every 6 years. So Harvey, Irma, Maria, and Nate were all retired from the list. So these are all the tracks. So quite an active season, some odd tracks. There's quite a bit of purple in there. The purple tracks are the major hurricanes. So hurricanes like Jose, Maria, and Irma all reached hurricane status, and then there's a few others but especially Irma, Maria, and Jose, they remained as a major hurricane for quite a long time, like an incredible amount of time that they maintained that peak intensity. Here in Canada, we got off fairly easy, another fairly easy year in terms of tropical cyclones for us. We had 3 that actually entered our response zone, which is delineated in yellow. So what our protocol is that we would start issuing bulletins specific to these storms whenever we expect a storm to cross that yellow line within a 72-hour period. So, and then we keep track of those storms. So for last year, we had 3 that entered our response zone, which is about average. However, none of these storms really cause any kind of impacts here in Canada at all. So we'll just go through the season here. Some of these we'll go through quite quickly. So we were actually at some hurricane meetings in the U.S. back in April of last year when we had our first tropical cyclone of the season, when Tropical Storm Arlene formed on April 19th. And it stayed out in the middle of the ocean and did not really cause any problems for anybody. Didn't see anything in May, and then our first storm in the official hurricane season was Brett, and then we also had Cindy form right about the same time, a couple of days apart, in the month of June. There was no impact from Brett, but Cindy did result in 2 fatalities in the U.S. because of flash flooding. Then in July, we had Tropical Storm Dawn and Emily. There was no impact from Dawn, but Emily again resulted in some flooding in the southern part of Florida. And then we had to wait till August, early August. We had Franklin, which became our first hurricane of the season, the first of 10 in a row. Franklin, again, didn't really cause a whole lot in terms of impacts. And then we had Gert. Gert formed in mid-August, but stayed offshore. It did reach Category 2 hurricane status, and as I showed in the tracks for Canada, you can see where Gert actually tracked as a hurricane. So we did get a little bit of swell arriving along the coast in Nova Scotia and Newfoundland, but otherwise no impacts with Gert. And then we had Harvey. Harvey started off as a fairly typical weak system in the middle of the Atlantic. It reached tropical storm status before affecting the Lesser Antilles. And then it actually weakened. It actually weakened to a tropical depression where it was barely trackable, but we were able to keep tracking it as it approached the Yucatan Peninsula, Mexico, and then once it crossed the Yucatan and made its way into the Gulf of Mexico, into the extreme warm waters in the Gulf of Mexico, which were above 30 degrees, everything else kind of fell into place. The wind shear dropped off to almost nothing, and that combined with the very warm temperatures result in very rapid intensification of Harvey as it approached the Texas coastline. And the image at the bottom here is the wind speed, so the basically the intensity of the storm. And you can see that from August 23rd right up until landfall, it very, very rapidly intensified. So it made it to Category 4 status just before making landfall in Texas. And the problem with Harvey is that once it did that, it didn't go very far. It stayed right in that general area and produced an exceptional amount of rain over that part of Texas. So it did make that landfall, as you can see on the satellite image at the top there, near Corpus Christi on the evening of August 25th as a Category 4. It was the first major hurricane to make landfall in the U.S. since that really busy season in 2005. The peak winds were sustained at 229 kilometers per hour, And around the fringes of the storm, it actually spawned 57 tornadoes, most of those being weak, which is what we tend to see with these hurricanes. When we have tornadoes that are spawned by hurricanes, they tend to be fairly weak, but they can certainly cause some damage. And there was some storm surge reported as a result of Harvey, 2 to 3 meters, and that will cause some damage along the Gulf Coast, but nowhere near what they saw with Katrina, for example. But the problem with Harvey, as I mentioned, because it slowed right down, and that in combination with another front that was north of Harvey, it resulted in just extreme rainfall over about a 5-day period. And the image on the top right here that I have highlighted in yellow, that was a tweet from the forecast office in Texas, basically saying this event is unprecedented and all impacts are unknown and beyond anything experienced. The rainfall amounts that forecasters put in these forecasts were not only above and beyond what they had ever forecasted in their career, it was above and beyond what they had ever seen in their career in terms of reported rainfall. So the highest in the analysis after the storm, the highest reported rainfall was 1,539 millimeters of rain. That was over about a 5-day period. However, we know that there's some areas that actually got more than that. There's some areas in kind of a swampy area where there are no rain gauges, but radar estimates tell us that there's anywhere from 1,600 to 1,800 millimeters of rain fell in that area. So not only were these numbers way over any kind of other record for a tropical cyclone in the U.S., the coverage of 600 plus millimeters was most of southeast Texas and into the western part of Louisiana. So we had a huge area of coverage that received over 600 millimeters of rain. So just unbelievable in terms of rainfall amounts. Now, if it's hard to compare, that amount of rainfall with other events that we may be more familiar with. So if you look at, if you compare the maximum rainfall associated with Harvey based on these radar estimates, it's more than double the annual rainfall for Toronto, for example, way more than the Calgary flood, the floods here in Halifax because of Hurricane Beth in 1971, Cape Breton floods 2 years ago, and the Toronto flood in 2013, all combined. So it's just an amazing, hard to imagine really that amount of rainfall. So the impacts from Harvey: 68 people died, 300,000 structures were flooded, 500,000 cars were flooded, 40,000 people evacuated or took refuge. There were reported over 30,000 water rescues, 11,000 by the Coast Guard alone. Lots of power outages, and some oil refineries were shut down for extended periods. So about 75% of the flood damage occurred outside of the 100-year flood zone, and that's typically what they advise people to do is if you're within that 100-year flood zone to get flood insurance in the U.S. and a lot of the flooding, like I say, was outside. It was so widespread that a lot of it was outside that 100-year flood zone, which means that about 80% of flood victims did not have flood insurance. And preliminary estimates for damage are 125 billion US dollars, and recovery is still certainly on the go there and will be for quite some time. So as we were still dealing with the impacts of Harvey, Irma developed off the coast of Africa in late August and became a hurricane early on August 31st. It eventually reached Category 5 status with winds of 290 kilometers an hour. and made landfall in Barbuda and St. Martin at peak intensity. So this storm made landfall on those two islands with sustained winds of 290 kilometers an hour with, of course, stronger gusts. There were two more landfall areas as a Cat 5, the British Virgin Islands and Cuba, and one as a Cat 4 landfall in the Bahamas. So lots of damage in Irma's path. It made a sixth landfall in the lower Florida Keys on September 10th, again as a Cat 4. And the final landfall, once it crossed the Florida Keys, it made its way up near Marco Island before basically crossing the spine of Florida. Peak wind was 257 kilometers an hour, and there was an unofficial report of winds up to 320 kilometers an hour. The peak wind in the U.S. was reported in the Florida Keys at 193. There were, compared to Harvey, quite about half the number of tornadoes were reported with Irma, but still they did get a few. One of the things that we were especially concerned about is the storm surge aspect. We were concerned about the positive storm surge on the east side of Florida. But meanwhile, while that was going on, the winds were pushing the water off the west coast of Florida. So that resulted in what we call a negative storm surge, which means the water actually goes out, and that basically exposed the ocean floor or the bay floor for people to actually go out. And that's what actually happened. Once this thing started to hit social media, people started to head out onto the ocean floor, take pictures, and there were all kinds of marine mammals that were stranded on the sand, and people wanted to go out and see that. What they don't understand or didn't understand is once that storm goes by, all that water is coming right back. And what I managed to get is the tide gauge data from Naples on the Gulf side of Florida, and you can see that that vertical red line is essentially how quickly the water came back once that storm, once the center of the storm passed north of that location. And luckily, nobody was killed because of this, but a very, very dangerous practice. And once we saw that, once the forecasters at the National Hurricane Center saw that, they got on social media and talked to their emergency managers and first responders to get people out of there, because that was an extremely dangerous thing to do. So impacts with Irma: 129 fatalities, 44 direct and 85 indirect. About $50 billion US in damages, widespread devastation in the Caribbean, with total destruction on the island of Barbuda. And the picture I have on the top, well, all these pictures are essentially the island of Barbuda. And it's just an amazing picture of the whole island in the eye of the storm. So right after the storm made direct landfall. And you can see the two pictures on the bottom. One was just before Irma on August 27th, and you can see it's nice and lush and green. And the satellite image on September 12th, which was a few days after Irma, and it's just nothing but brown. Everything, all the vegetation had died, and they evacuated most of that island as Irma was approaching, but once the storm went through there and damaged pretty much all infrastructure, I think there was about 100 people left. But right in Irma's wake was Jose. So we feared that Jose was going to impact Barbuda just a few days after Irma. So the few people that remained on the island actually evacuated after, as Jose was approaching. So that was the first time in 300 years that that island was totally uninhabited. So certainly history there. There were 150 homes damaged in Cuba, and the lower Florida Keys were just devastated by Irma. was the largest evacuation in U.S. history. That's 6.8 million people had to evacuate. There's significant flooding along the east coast of Florida, especially in the Jacksonville area, and it was the worst that they had seen in over 225 years. The wind impacts from Irma extended well into the Carolinas and Georgia, and there was a lot of focus on the storm about different models, the European model versus the U.S. model, and basically a misinterpretation of what the forecast really means, and that caused some confusion as the storm was approaching. And if you go back and you look at every forecast that was issued by the National Hurricane Center in Miami, every forecast, the storm remained in the cone for every forecast that was issued for Irma. It was an exceptionally good forecast, but because of some misinterpretation, there was some confusion as the storm was approaching Florida. So now, as the season continued, as I mentioned earlier, we had Jose that formed in early September. Again, another one of these rapidly intensifying storms that went from barely anything to a Category 4, meandered off the coast of, it actually did a loop and then meandered off the coast of the U.S. for a few days. Then there was Katia. Katia was a short-lived Category 2 storm that formed in the Gulf of Mexico, and at one point we had 3 hurricanes on the go: Jose, Irma, and Katia. So again, a very busy week for sure for the folks at the Hurricane Center in Miami. And then we had Lee that formed in mid-September as well and reached major hurricane status, but thankfully stayed offshore. Then we had Maria. Maria also formed over the central Atlantic in mid-September. It rapidly intensified, again reaching Category 5 status with winds of 282 kilometers an hour. It ravaged the island of Dominica with winds of 269 kilometers per hour. And as we remember, it made landfall in Puerto Rico with winds of 250 kilometers an hour before moving up and kind of slowing right down off the coast of the Carolinas. So that, and thankfully, you can see the track here on the top right-hand side, and it made quite a sharp turn towards the east. And based on that motion, it was kind of poised to impact either New England or us here in eastern Canada, but thankfully there was an area of high pressure to the north that resulted in that very sharp right turn, and then it stayed out to sea. The radar image that you see on the bottom is the last radar image from the San Juan radar, and these are some pictures from Puerto Rico. The top picture here is actually what was left of the radar. There's a tower here, and at the top of the tower is usually a dome with the radar, so that blew that to pieces. So there were 112 fatalities directly as a result of the storm. However, the estimates are very tough to come up with an accurate estimate. There was just something in the news in the last few days that indirect fatalities are well over 1,000. And there was $90 billion in damage, so that made it the third costliest hurricane in U.S. history. The electric grid was devastated. Practically all cell phone service was lost, and municipal water supplies were knocked out. And they're still very much in the recovery phase today. And as someone from FEMA mentioned to me down in the U.S. Earlier this spring, they're just a mid-level tropical storm away from bringing them right back to the day after Maria. So their recovery is extremely fragile even today. So then we had Hurricane Nate. Nate was a Category 1 storm that formed in early October, and Nate is the fourth of those storms that will be retired, and that's because it created a tremendous amount of rain in Nicaragua, and that caused a number of fatalities as a result of mudslides there. And then it actually impacted the Gulf Coast of the U.S. as well, caused some flooding there. So a total of about $800 million in damage as a result of Nate. And then this was another one of those weird tracks where we had Ophelia storm that formed in October and became the final hurricane of the season. It did reach Category 3 status and then moved up towards Europe, which is an odd track. It affected Europe with winds gusting as high as 190 kilometers an hour. And the picture you see there is an orchard in Ireland, I believe, where it knocked all the apples off the trees. And you can see there's just a sea of apples there. Thankfully, they were able to recover a lot of those apples, but not a scene that you see very often up there. Following Ophelia, we had Philippe, which was a tropical storm, and then the last storm of the season was Rena, that formed in the month of November. So as I mentioned, really a record-setting storm. It was the 7th most active storm in the last 167 years based on storm energy. We had 6 major hurricanes that formed last year, the most since that hyperactive year in 2005. It was by far the costliest year for hurricanes in the U.S. with $265 billion in damage. We had 3 of the top 10 costliest hurricanes all occur last year. As I mentioned earlier, 5 Category 5 landfalls, which is just amazing. To get 5 to get even a Category 5 storm in any particular year is something you don't see all the time, but to get enough of them so that you have 5 landfalls as a Category 5 is just amazing. 3 Category 4 landfalls in the U.S. in 26 days. There were only 3 in the previous 56 years. Again, amazing. First time that the U.S. had 2 landfalling Category 4 hurricanes in the same year with Harvey and Irma. So it's even in that 2005 year, there weren't 2 Category 4 landfalls. There were 2 last year. Record-setting tropical cyclone generated rainfall with that recorded 1,539 millimeters. There were 37 cases of what we call rapid intensification. So a storm where the winds increase at least 55 kilometers an hour in a 24-hour period. So there were 37 cases of that last year. And that is one of the things that forecasters are most concerned about, because those kinds of situations are extremely difficult to forecast. So out of those 37 cases, only 6 were correctly forecast by the National Hurricane Center last year. So that's a focus of a lot of their attention, is to try and capture those rapid intensification events. So Ophelia, that was that storm that hit Europe, was the farthest east that an Atlantic major hurricane had been observed. So again, we're seeing things that we really haven't seen before, and that's part of what made last year an absolutely historic hurricane season. So with that, what might we expect for this year? Well, we look at a number of things at this point in the season, or just before the season starts, to kind of indicate, try and get some indication of what the season will be like. The first thing that we get is, as we look at, is water temperature. So in terms of water temperature in the Atlantic, this is what we have right now, or this is what we had last year, right about this time. And the red areas indicate areas of water that's basically warm enough to support hurricane type activity. So the red and the dark oranges indicate that. So that was last year. If we look at this year, you can see it's not quite as warm as it was last year. So just go back here. This was last year, this year, last year, and this year. So the water, first of all, is not quite as warm as it was last year. So we need to take a look at what the anomaly is. How different is it compared to the normal water temperature that we typically see at this time of the year? So if we look in the tropics, which is down just above 10 degrees north, and you can see that the water is actually cooler than the normal water temperature for this time of year. What really draws your eye is obviously this patch of warm water that's in the northern part of the Atlantic and just off the coast of Atlantic Canada, or specifically the Maritimes. That's all well and good, but even though the water is warmer than average there, it's still not warm enough to generate any kind of tropical activity. The important area is off the coast of Africa, where the water temperatures are about 1 to 2 degrees cooler than what they should be at this time of the year. So with that gives us our water temperature component of the hurricane season a little bit below average. Now we think that as we go into hurricane season, by the time we hit August, that water temperature will be a lot closer to average. So that anomaly won't necessarily be negative once we reach the August-September timeframe. But if it stays cold, then that might bring the numbers down a little bit. So the other thing we look at is wind shear. So as I mentioned, hurricanes don't like an atmosphere with a lot of wind shear, so we don't want a lot of wind shear. So one of the things we look at for wind shear is whether we are in an El Nino or not. And an El Nino is essentially a patch of warm water off the coast of South America, so that large rectangle, and that was this again last year. And you can see the water temperature anomaly off the coast of Africa was a little bit above average, so into the yellows and oranges. Meanwhile, the bigger rectangle in the Pacific was again a little bit warmer than average, a little pocket of colder water, but essentially a little bit warmer than average. If we look at what we're looking at right now, again, that area of cold water in the Atlantic really kind of pops out at you. And there's not really any kind of clear indication over the Pacific. So as long as that area over the Pacific is not a lot warmer than average, we don't have an El Nino. Therefore, we don't have an increased amount of shear in the Atlantic Ocean. So if we look at what we expect El Nino to do over the next few months, and when we look at El Nino, we have to measure it over a long period of time, so 3 months. So the middle of this graph, the ASO, ASO stands for August, September, and October. So basically, this is the NOAA prediction for El Nino, and they're only calling for about a 38% chance of El Nino by the time we get into that August, September, October timeframe, which means that wind shear is not lower than average, but it's not higher than average. So we don't expect a very negative wind shear over the Atlantic this year to keep the numbers down. So the last thing we look at is something called the multi-decadal cycle. So the multi-decadal cycle is essentially a cycle that occurs on the order of 20 to up to 40 years, where we see water temperature in the Atlantic being colder or warmer for extended periods of time. So we have been in a warmer or more active hurricane period now since 1995. So that's over 20 years. And basically, it's very difficult to measure. And the way we approach it is, as long as there's no clear evidence that we're in a negative phase, we have to assume that we're in a positive phase. So we expect, since there's no real indication that we're in a negative phase. We're assuming that we're still in an active phase, which would favor a bit more hurricanes than the average. So looking at all these three components, kind of a colder water temperature, average wind shear, and an active period, based on these factors, this is what NOAA came up in terms of their predictions for the 2018 hurricane season. So you can see that the 10 to 16 named storms is right around the average or slightly above. Same thing for hurricanes with their 5 to 9, which was incidentally the same forecast that they had last year for the number of hurricanes. And the number of major hurricanes is anywhere from 1 to 4, and the average is 2. Now, that's the NOAA predictions. Another agency that actually predicts the level of activity in the Atlantic every year is Colorado State University. They just updated theirs. They issue their initial forecast in early April, and then they updated right before hurricane season. So they actually updated their predictions today, and their predictions are for 13 named storms, 6 hurricanes, and 2 major hurricanes. So basically, they're looking at about an average season. So that seems quite reasonable that we are in that near average to above average, slightly above average. I think one of the main things that we're going to have to watch over the course of this hurricane season are those water temperatures in the Atlantic. I don't think we're going to get into an El Nino by the time we hit August, September. So the most important thing is going to keep an eye on those water temperatures in the Atlantic to see if they warm up over the course of hurricane season. So what does that mean for Canada? Well, we keep track of the percentage of storms that enter our response zone versus the total number of storms in the Atlantic, and we typically find that about 30 to 40% of the storms that form in the Atlantic find their way into our response zone. It can vary from about 30 to 35 or 35 to 40, depending on the year. In the last few years, it's actually been fairly variable, the percentage of storms that make it into our response zone. So the names that we'll be using this year, the first one we've actually already had, Alberto, so we're already at 1 before the official season actually starts. So following Alberto, the next storm will be Burl, followed by Chris, Debbie, Ernesto, and so on. So the last section here is just to go over some websites. I'm sure most of you are aware of these websites, but may not have a good feel of what information to look at what phase of the storm or at what time frame. So just to make the distinction between what we do at the Canadian Hurricane Center and the National Hurricane Center in Miami, the National Hurricane Center is what we call the Regional Specialized Meteorological Center. So the World Meteorological Organization has given them, of which the WMO Canada is a part of. So we've given Miami the distinction of RSMC for the Atlantic and the Eastern Pacific. So they are the center that keeps an eye on the Atlantic 24/7. For us here in Canada, we monitor things as well, but we don't necessarily issue bulletins or track forecasts on every storm that's out in the Atlantic. We focus on the storms that will have some sort of an impact on Canada or our offshore waters. So our protocol is to send out, initiate sending out detailed weather information on a particular storm that would include the track forecast, our own CHC track forecast, and our text bulletins on a storm, 72 hours before the center of the storm crosses that response zone. So we want to give people enough time to start preparing. So we will actually add a lot more details for what we expect over Canada than what you'll find in the bulletins that come from Miami. So if you're monitoring activity in the Atlantic, usually the first place to go to for information will be not the Canadian Hurricane Center, but the National Hurricane Center. And they will have what they call their graphical tropical weather outlook, which tells people, alerts people to areas where tropical cyclone formation is likely over either a 2-day or a 5-day period, and they'll attach a probability of formation. Once a storm actually forms, then there's a whole other suite of information that they have, including the track forecast and their cone of uncertainty. Talk a little bit more about that in a second. And then they have things like wind speed probability maps. So the probability that the winds will exceed, say, tropical storm force strength or hurricane force strength. They'll also have the wind history, so it tells you how big the storm is. It has graphics that indicate the time of arrival of tropical storm force winds. So that gives you kind of a point to which you have to be to which you have to have all your preparations completed by before the storm actually starts. It'll have storm surge and rainfall maps, and over the last couple of years they started to do something called key messages, something that can be used in social media, something that's very user-friendly and written in terms that everybody can understand. So that graphic is available on there. You can just download that and tweet that out, sort of thing. And as the storm gets closer to Canada, that's where you kind of migrate a little bit more towards the Canadian Hurricane Center and our suite of products, which again includes a forecast track that was issued by our forecast here. Any forecast track that you see on our website that's in blue was issued by forecasters here, whereas any track that shows up in red will be issued, that means a storm where the track shows up in red means that we don't expect it to enter our response zone within that 72-hour period, and it means that the track has been issued by forecasters in Miami. Typically, there's not a big difference between any of these tracks, to be quite honest. The other suite of products, we have 2 text bulletins. One is a kind of a general bulletin that's written in plain language, and we have a second bulletin that is written in, it's more of a technical bulletin for other forecasters and some of our more savvy weather users. So by starting off, if a storm is expected to form, if you're doing a weather check every day and you expect something to develop, the place to go to would be the National Hurricane Center Tropical Weather Outlook. If a storm actually does develop, you can start looking at, again, the NHC stuff and start looking at our website to see when we expect to start issuing bulletins. Typically, even if the storm is beyond 72 hours of crossing the response zone, we'll issue like a bulletin once a day to say, this is what the storm is doing, this is what we're expecting, and this is when we plan to initiate bulletins from the Canadian Hurricane Center. So we'll still have some information out there if a storm is expected to somehow move up over Canada. So once you get into that 2 to 3 day time frame is when we'll start adding a lot more details in terms of what the expected impacts are going to be. And 1 to 2 days out is when we would have the most amount of detail, and we'd also start to issue our tropical storm and hurricane watches and warnings. So there's a suite of products that we have on our website as the storm approaches. So I mentioned the track map and the cone of uncertainty. The cone of uncertainty is basically made up of the average errors in the forecast position of a storm in certain time frames in the future, anywhere from 6 hours, 12, all the way up to 120 hours, which is 5 days. Last year, the National Hurricane Center beat their record for the lowest track error, or in other words, the best forecast that they've issued at all of these different times, 6 hours all the way out to 120 hours. So the cone that you see this year is going to be about 11% smaller than it was last year. So the cone keeps getting smaller and smaller, meaning that the errors in position of these storms keeps getting smaller every year. So the forecasts keep improving. So the errors this year that are going to be used this year to build the cone. So for 5 days, the average error is 367 kilometers. So that basically means that if you look at the position of a storm 5 days out, it could be almost 400 kilometers on one side or 400 kilometers on the other side. So still some fairly large errors to make critical decisions on 5 days ahead of time. So what you have to do is keep monitoring the forecast on a daily basis to monitor any changes in the track as we get closer to the event. Even if you're looking at the pure details of the storm, even 24 hours out, the storm could be 80 kilometers on either side of where the track is. So that is what these forecasts actually mean. So with that, that ends the briefing for this year, and I guess we can open it up for any questions.
Thank you very much, Bob. This was a great presentation. If anyone on the line still has questions, I'd invite you to write them down in the question box at this time. So I have a couple questions for you. First of all, the numbers you showed for this year versus the predicted numbers for last year, they seem somehow similar. For the named storms and hurricanes and things like that, what explains the fact that the 2017 hurricane season turned out to be more severe than predicted?
One of the things that, as I mentioned, that we look at is whether or not we're going to have a lot of wind shear. So we look at whether or not we're going to be in an El Nino. The problem in doing that, however, is that El Nino is notoriously very difficult to predict in the springtime, because things are changing both in the atmosphere and in the ocean at a faster rate than is what happens in other times of the year. So to try and predict what the El Nino is going to be in late summer and fall, the worst time to try and make that prediction is in the springtime. So that's what we were looking at last year. The early predictions that came out last year accounted for a stronger possibility of an El Nino by the time we reached the peak of hurricane season, which never really happened. The forecasts that were issued by Colorado State in early April in 2017 called for quite a lower number of storms. By the time NOAA issued their forecast in late May, so 2 months later, it became clear that El Nino wasn't developing as fastly as we had originally thought. So the numbers from last May were actually higher than what Colorado State issued in early April, 2 months before. And then NOAA, the numbers that we just looked at today, they update their numbers again in early August. And in early August, they bumped their numbers up even higher than what they had in May. So all the forecasts were constantly being adjusted upward as we headed into the hurricane season last year. But the main reason why the season was busier was because of an over prediction of El Nino, which never really materialized.
Okay, this is very helpful. Thank you, Bob. One thing we've seen in the news recently is the headlines about subtropical storms hitting the Gulf area and Louisiana in the United States. Could you briefly explain what's the difference between a subtropical storm and a tropical storm?
Yeah, when we get a pure tropical storm, there's an area of disturbed weather, but it's not an existing area of like a low pressure center. And basically what you get, you're starting from nothing and you're building thunderstorms, and then your thunderstorms start to get organized in a rotational fashion that start to rotate around the center. That's the development of a pure tropical storm. In the case of a subtropical storm, there's already an area of low pressure there that did not originate as a tropical storm. It's an existing low pressure center. So once that area or that existing low pressure center is there, that's when it starts to acquire tropical characteristics. And if it acquires enough of those tropical characteristics, it is basically classified as a subtropical storm. So a tropical one is one that starts on its own, and the subtropical is there was an existing little, like a mini storm there, if you will, and then it acquired tropical characteristics to kind of become a sort of tropical storm that we call a subtropical storm. So in the case of a subtropical storm, it has both characteristics of a regular type storm and a tropical storm as well.
Okay, this is great. Thank you. You talked, sorry, were you going to add something? Okay, we have we have a question on the line. You talked a lot about the different ways we can get information about hurricane warnings. We have someone asking what type of marine impact information is posted on these warnings when there's a threat of a hurricane.
Yeah, on the on our bulletin, the one that is meant for the public, not necessarily, actually, well, both bulletins that we have, our public bulletin and our technical discussion, has a section for marine impacts. So the way if I go back here, so the structure of our bulletin starts with a summary of the information about the storm. So the position at that time, where it's going, what the intensity is, and then we have a section for public impact. So we summarize the warnings that are in place and what the hazards and potential impacts might be. And then below that, we have another section that's specific to marine impacts. So we summarize all the marine warnings, and we talk about the potential impacts in there as well. So if you go to our website, if we have a storm approaching Canada, you go to our website, you click on the bulletin. If you scroll towards the bottom, you'll get all the marine information there.
Okay, that's great. And when you talk about this marine information, are we talking about storm surge or things like that, or what kind of data can we expect to?
Yeah, there's a couple of different things. If we're expecting a storm surge, it will be mentioned in both the public and marine impacts. Because if a storm surge doesn't mean a whole lot, away from the coastline. So anytime we have the potential for a storm surge, it's going to impact marine interests. It's also going to impact the public. So it will be mentioned in both of these sections, in public and marine. In our technical discussion, we'll also have a table that summarizes the radius of the different wind speeds around the storm. So we might mention something like over the northeast quadrant of the storm, The hurricane force winds extend out to 20 nautical miles, and the tropical storm force winds extend out to 80 nautical miles, whatever the case might be. So we'll have the wind radii for all these different wind speeds in our technical discussion as well.
Okay, that's great. Very helpful. Thank you. You showed us on one of your slides where the response zone for Canada is versus the response zone from the U.S. And you mentioned that generally NOAA will provide a first map if a storm was to form and a first bulletin. Does the Canadian Hurricane Center also create their own maps, or is it largely based on what comes out of the United States?
Yeah, we create our own maps, again, only if the storm is expected to cross that response zone within a 72-hour period. And for any other storm that's out there, we will still display it on our map, but it will the track map will be displayed in red, meaning that we basically took the data from Miami and imported into our own map. If you see a track in blue, that means that track has been issued by the Canadian Hurricane Center. But however, it doesn't make any good sense to have two completely different tracks. So our track, if we issue one, if a storm is approaching Canada and we're actually issuing a track, it should never be that different than what is issued by Miami. However, that being said, there are some times when there are slight differences in our track and in the Miami track. That can happen for a couple of different reasons. One, we don't issue our track maps at the same time. So there can be times when we get new data that Miami hasn't received yet, and we update our track before they update theirs. So that might lead to some discrepancies between a Canadian track and a US track. There are other times when a storm is approaching Canada and we think the track might be a bit more one way or the other, and that difference might be a big difference in terms of impacts for Canada, but for the US they may not appreciate that difference, so they'll stick with what they have. So there have been examples of both of these situations, but in general we try to stay pretty close to what is issued by the Americans, because it does nobody any good to have two conflicting tracks out there.
That makes sense. Thank you. You also mentioned in your presentation that, and I believe you mentioned the same thing last year as well, that there's some storms that tend to happen before the start of the hurricane season or after the end of the formal hurricane season. Do you see from your experience, are we experiencing more of these storms than before? And similarly, can we expect to see more storms happening outside of hurricane season in the future?
That's a good question. It's actually something that's being debated in amongst the hurricane experts. It looks like we are seeing a few more storms developing early in the season, whether it's just prior to the official start of the season or early in the season after June 1st. What is more difficult is to differentiate between, are we actually getting more storms, or are we just getting better at detecting them? Because our tools to detect these things are just almost not comparable of what we have now compared to even 10 years ago. So the fact that we're actually detecting more storms doesn't necessarily mean that there are actually more out there. So that's kind of the discussion that's actually occurring right now.
Well, thank you. This is really helpful. I have two more questions, but I'd just like to invite everyone else on the line, if you have any remaining questions, to ask them in the question box at this time. So following up on what the answer you just gave us, you mentioned in your last slide that I believe the predictions are 12% or something like that, better than they were last year, and that they keep getting more and more precise. every year. How do you see these predictions evolving? Are we going to keep seeing more and more precise predictions, or what's going to change in the years to come in the way we predict tracks and landfalls and things like that?
Yeah, that's another great question, and something that there was actually one of the hurricane forecasters from Miami, Chris Lancy, actually made a presentation at an American Meteorological Society conference just a few months ago about that exact topic, and the title of his presentation was, "Have we reached a limit in the predictability of hurricane tracks?" So it's a good discussion. At some point, we are going to reach a certain limit. We're never going to be able to predict these tracks 100%. However, we're certainly getting better every year. Sometimes we get a lot better. Sometimes the difference is very small, but it's continually improving, which means that cone is getting smaller and smaller, which means that expectations that the storm will be within that cone are even greater. And any kind of misinterpretation of the cone, like we had last year with Irma, where the impacts, all the cone is where we expect the center of the storm to go. And it says nothing about the impacts. In the case of Irma, the storm was much, much bigger than the cone. So we expected impacts all through Florida, yet people focused on that cone. So although we're getting better at forecasting where the storm is going to go, we still have some work to do in continually trying to get people to understand what the cone actually means. So that's one thing. The other aspect of forecasting specific storms, and I mentioned it in the presentation, is this thing about rapid intensification. We're continually getting better at forecasting the track. However, rapid intensification, we still have a long way to go. And that really, when you think about it, is one of the most dangerous things, because if you have a storm like Harvey that goes from a weak tropical storm to a Category 4 hurricane in 36 hours, that doesn't give people a whole lot of time to prepare. So it's that intensification or intensity forecast that needs a lot of attention from forecasters, because that still is not as good as certainly the track forecasts are right now.
And thank you very much, Greg. Bob, this is very interesting. One last question. You just talked about predictability and intensification of storm. And this also affects, obviously, when the storm makes landfall. How have you seen the characteristics or impacts of a storm changing when it makes landfall, as opposed to when it's still on the coast or in the ocean?
Well, these things exist because of the warm water. So as soon as a storm makes landfall, it starts to rapidly lose its intensity. And basically, we have a rule of thumb where after a storm makes landfall, it loses half of its intensity for every 12 hours after landfall. So in the case of Harvey, although the storm made landfall as a Category 4 and then began to weaken fairly rapidly, despite that, most of the rain that fell as a result of Harvey fell while the storm was a tropical storm, not while the storm was a Category 4 hurricane. So it's important to make that distinction, that we can get severe impacts even from things like a tropical storm if other conditions line up.
Absolutely. Thank you very much, Bob, and again, thank you so much for this great webinar. It's always a pleasure to have you every year, and we hope you'll continue to visit us every year at this time for the years to come. So thank you very much. I'd also like to let everyone on the line know that we're having our next Friday Forum on Friday, June 15th by Charles Cawthorn from the University of Kyoto, who is currently visiting at University of California, Berkeley, and it will be on wildland-urban interface fire. And everyone, Bob, again, everyone on the line is also sending thank you messages for a great presentation. So again, thank you very much, and we hope to have everyone on the line back for the June 15th webinar. So thank you.
Thank you.